Okay, and we are redirected to the experiment overview, where we can see all our experiments here. I'm gonna zoom into our TCP Reno versus Tahoe, um, and we're going to see what actually happened. So the first view is our packet simulation, where we can see the packets flowing between each node. Now, depend on the size of your experiment. In our case, it's only 206 packets, so it's not so bad. But if you have a bigger experiment, then it might take a little bit longer. On the right side, you can see the legend. For each flow, you have a different color. For drops, it's red color. Okay. Now we're going to click play here. Both Tahoe and Reno send scene segment, and the servers reply with an acknowledgement. This is a very normal behavior of TCP. Um, Now what happened is both Reno and Tahoe will go into slow start phase, where they will increment the congestion window by 1. I'm gonna speed things up a little bit so you guys can see. Again, there is no much difference between TCP Reno and Tahoe. What I'm gonna do now, I'm going to slow simulation a little bit. And if you guys remember, around this time here, we schedule a link failure for this link and this link. So what will happen is we're going to drop one packet out of TCP Tahoe and one packet out of TCP Reno. Now the link failure will be very short, so you can barely see it. There we go. I have a first drop and our second drop, and all other packets are continue regularly. I'm gonna pause and I'm going to click on packet 7 here. What we can see is packet ID 7 sequence 30, and it belongs to node Reno. So I'm going to click on 7, packet ID 7, send packet ID, packet ID sequence, packet sequence 28, but this one belongs to a different flow. It belongs to node Tahoe. So again, one drop for each flow. Continue a little bit faster. All right, pause again. What we can see here is that the server is replying with the acknowledgement. Now, these acknowledgements are basically duplicate X. What this means is that the servers are trying to tell the senders that we received the packet, but something went wrong. We didn't really receive the packets in order. So if we click on this acknowledgement, we can see packet ID 6. If we click on this ACK, we can see packet ID 6 again, and on the third one, packet ID 6. Same things goes for TCP Reno. It's no difference in this case. Play it. Okay, so what will happen now? Tahoe and Reno will implement the fast retransmission. which means on the third duplicate ACK, they will retransmit the packet. So when the first duplicate ACK was received, both Tahoe and Reno just transmit regularly. Second, transmit regularly. So this packet here is going to be regular transmission 15. This packet here is going to be let's move it a little bit, 16. And the third packet is packet ID 7, which means retransmission. Same things goes for TCP Reno, 15, 16, and retransmission. The difference now between TCP Reno and TCP Tahoe is that Reno will go back, Tahoe will go back to slow start all over again. It will drop the congestion window to 1, which means a very drastic act, while Reno will implement the fast recovery phase, which means it will not go back to slow start, but it will reduce the congestion window back to 1, but it will add another 3 times segment size, 3 times the segment size. Question is why 3? And 3 is because it received 3 duplicate acts, which means there are still three packets leaving the network. If we're going to speed things up a little bit, we can clearly see that node Reno, TCP Reno is transmitting more packets from Tahoe, and this is because the window size at Reno is bigger than TCP Tahoe. I'm gonna pause now. I'm gonna change the view for the throughput view. Downloading. All right. So first thing to see is the orange belongs to Tahoe and the green one belongs to Reno. Uh, we can see that Reno finished at 1.9 to send 50 packets, but Tahoe at 2.1 second. So Reno finished much earlier, and the throughput is much higher than Tahoe. This is because, well, number of packets are the same, like it's 50 packets, but Reno did it in much shorter time than Tahoe, which is, of course, good. We click on the congestion window chart, the last one, and this is where actually things are happening. Again, the difference between Reno and Tahoe is that Tahoe go back to slow start, while Reno implement the fast recovery. Okay, we zoom in. So at the beginning, we can see the slow start mechanism, CWND equal 1 for both. After round trip time equal to exponential growth 3 and 4, 5, 6, 7, and 8 for both Tahoe and Reno. But when the third duplicate ACK was received, you can see that Reno did not decrease back to 1, but it's equal. If you see the blue one is equal to 4, which is 1 plus 3 times the segment size. We go back to the end. At this point, Reno finished to transmit and Tahoe is still transmitting. That's it. Thank you very much for watching.